Hi, welcome all. I have started working on Red Hat OpenShiftAI container, or that server sandbox environment that's being given to me from Red Hat. As promised, I was selected for this Red Hat hackathon. What it holds is like we can create workbenches. Like if we go back to the Red Hat server itself, here you can see like you have an overview of the workbenches, the pipelines, then models, other thing, cluster storage, data connections, then permissions that you have the other things also. So applications, you can see like there might be which one is enabled for you to get started with. So I created one container for the workbench. So workbench is a notebook server that contains PyTorch, QDAS 12.1, Python 3.9, PyTorch 2.2. So it's running the Intel image that's been given to us from Red Hat, and accordingly I started my experiment and I improved on my logic, or say the experiment that I was doing with drug discovery. There are a lot of moving pieces that I have done currently. So first of all, if we look at the coding logic too, there had been some changes, like we have used stopping and also learning rate scheduling for this. So we have optimized the data loader, we have taken that and consideration, and finally the output has been saved. Like there has been saved the final model after training completes, that's done. And after that the training happens, it goes through all the details, like the final model is saved at this path. We can visualize the molecule, created a Gradio app, and I will show you some functionality, like some of the smiles that we have. So if we use this smile, it is lipopropene. So if I just use it over here, it is like a tool that shows the lipophilicity of a molecule. So what is exactly a lipophilicity? It is a chemical property that describes a molecular tendency to dissolve in fats, oils, and non-protein. But the added factor that I have taken into consideration when I was doing a model training is that it gives some value for if it is optimal, it is high, it is low. So if we just pass this smile over here and I click on submit, you will see like the Gradio app is running. This is in the Intel Red Hat OpenShift container that's been given to us, and it shows that it's currently optimal as the result should have been. The molecule has a balanced lipophilicity, suggesting good permeability and solubility favorable for drug-like properties. We'll take into consideration other smiles too. Let us take this smile. So smiles are the ways we can create the molecules or share the details of it. If I just click on submit over here, you'll see like the lipophilicity is high. The molecule has high lipophilicity, indicating good membrane permeability but potential risk of bioaccumulation and poor water solubility. Okay, so it gives the total details of it. So this is a very handy tool for people who are working on fields of drug discovery. There can be a lot of things that can be implemented with it. And after that, let's test with another smile too. I will just pass it along. Okay, so if I pass this smile, I click on submit, you'll see that it has low lipophilicity. So we have covered 3 different conditions, and if you see in the code itself over here, the changes has been made accordingly when it happens for lipophilicity of a smile. Okay, so if you see to this point where I have my interpretation, included the interpretation of lipophilicity with higher lipophilicity, so you have all the options being created. Now the changes have been incorporated accordingly. Okay, thank you.